Today we're going to be taking a look at OOP, or Object-Oriented Programming. Now before we begin, I want to note that although this tutorial will be in Java, the concepts that you've learned from this tutorial can still be applied to other OOP languages such as Python or C++. Alright, so the aim of this tutorial is to create a person object, but before we create an object we need to create the class. You can think of the class as a recipe for the object. So what does this recipe involve? Well, it involves some basic syntax that's specific to the language that you're using. For Java, that is just public, class, and then the identifier. So we're going to be using person as an identifier, and that should be the same name as the file in Java. Now we also need some ingredients. Now these ingredients are the class fields or the class variables. These should be things that are specific to this class. So for a person, that can be something like a name and an age. Next thing we need is a way to initialize these two variables. We do this in what is known as a constructor. This is where we set the variables to default values. So we can set this .name equal to name and this .age is equal to 0. We can also create an alternative constructor. Now this will use parameters to set the variables, so person. So the two parameters here would be name, so string name, and int age. And what we can do is we can just set these two variables to the imported parameters, right? Note that in Java, when we use the keyword this refers to the class field. And because there exists local variables with the same name as the class fields, we need to use this to differentiate between both of them. This is the same for languages like Python and JavaScript, where we use self or this to differentiate between local and class variables. So we have those two constructors there. Now we're going to look at the copy constructor. Now this allows us to copy the attributes of one object to a new object. So person, and we can actually import the another person object into this, so p, and what we want to do is we want to grab the attributes from the other person class into this new person class. But the issue with this right now is that we have no way of accessing the name and age because these are private fields. So what we have to do is we have to create something known as getters and setters. Now the getters and setters are pretty self-explanatory. They're just ways of accessing the class fields. So for instance, a getter for the name would look something like this. So we would have public, because we want to be able to access this function from anywhere. And we want to return a string because this is a getter of a string. And we can just say get name, and we don't need any parameters there. So, and inside that function, all we would do is we would type return this .name. Right, we can do the same thing for the age, so public int get age, and we can just return this .age. So these are what are known as getters, or alternatively accessors. Now we'll look at setters. Now setters should be pretty self-explanatory as well. So basically, rather than returning something, we're not going to return anything, and we're going to call this one set name, and this is going to take the parameter of string name. And basically we just set the name variable, so this .name is equal to name. Now looking at the age, we can also apply some verification here, or validation. So again, we're not going to return anything, but what we're going to do is we're going to import the age, so int age. Inside the method, however, we're going to ensure that the age is not less than 0. So if age is greater than or equal to 0, then we can set the new age, we can set the age to the new value. Else we can either throw an error or just leave it as is. And we're just going to leave it as is for now. So that's the basic boilerplate for an object. Now obviously we can add whatever functions we want to. So for instance, if we wanted to add public void birthday, what this would do is we can allow it to increment the age. So this .age plus equals 1, right? Alright, so obviously you could replace the birthday with whatever function you wanted to, as long as it was relevant to the class and it you know, it did something that was not just completely abstract to the actual concept of the class. So now we need to create the object. So in the main entry point for the Java program, what we do to create the object is we note down the identifier that we use. So we use person, right? So what we can do here is we can type person. So this is the same as if you were to identify a variable as a string or any other primitive object type. So we have person, and then we have the variable name. So we can call this one p1, and we want to use the default constructor for this one. So what we can do is we can type new person, and we're not going to pass any parameters. What that's going to do is it's going to look into the class, look for the signature with no parameters, and then it will use this one. And we'll just print out the attributes of that person. So let's go ahead and type system.out.print, and we'll type. Alright, so you notice that I use the accessors there because we have no way of accessing the private variables inside there. So that's why these accessors are quite important. Now, I really don't want to have to do this for every single specific person that we create. I want to be able to kind of I still want the same format, but I want to be able to do that without having to type that over and over again. So what I can do is I can come down to the class definition, and I can do something like public string to string. Now this is a common function inside a lot of classes, and what I'll do is I will just type return, and we can do something like person, and we can export it as a JSON kind of format. So person, right? And rather than, you know, having to do this all the time, what we can do is we can just call that function. So p1.toString. Okay, so that's another example of a common function that you would use inside a class definition. Now we'll do the same thing for a couple more people. So, and obviously we'd replace the variable name. So p2. Oops. Alright, so we want the alternate constructor for this one, so we can just pass in a couple of a string and an integer. Jack is 24, let's say. And for the copy constructor, because we now have access to the getters and setters, what we can do is we can set the variables to use the accessors. So this dot name is equal to the person that we're importing as a parameter dot get name, right? And this dot age is equal to p dot get age. Okay. So now we'll just pass in the p2 to that function. And let's go ahead and run our program. So I want to see if I can open up the terminal here. Yep. And what we're going to do is we're going to java. No errors, that's good. And we'll just run that program. So you can see the default constructor has used the default values. I'm just going to try it. Nope, I cannot zoom in. So we can see that the first person has used the default values. The second person has used the values that we passed into as parameters, and the person 3 is just an exact copy of the person 2. Alright, so now that we have that, we'll run the birthday function just to show that it actually works. So we'll do p3.birthday, and this should be different from the p2, because when we pass in the parameter here, it's just creating a copy of p2 at the time that we call this function, but it's never going to keep up to date with p2. So let's go ahead and run that again. So we'll compile, and you notice that p3 has a different age to p2. Alright, so just to recap on what we actually did, We created the basics layout for the class, so that involved the basic syntax and the identifier for the class. We then introduced field variables or class variables. So these were the name and age. So to initialize both of those, we created 3 different types of constructors. The first one is known as the default constructor. Now this just sets the default parameters. The second constructor is known as the alternate constructor. Now we could create many variations of this as long as it had a different signature. And what this did was it used the parameters that we took in and modified the age and name to be those parameters, right? The third constructor we created is known as a copy constructor. Now what this did was it took a object of person and copied the values from that object to this new object. We then took a look at getters and setters. So getters, again, is pretty self-explanatory. It's just a way of getting the variables. The setters, again, very self-explanatory, just setting the variables or the class fields. Now we can obviously add a whole bunch of other functions as long as they're relevant to the class. So we have toString, which gives us textual information of the current state of the object, and we have just a random object there for the birthday. So that should cover the basics of OOP and allow you to hopefully use this to, manage your programs a lot more efficiently compared to the standard procedural programming. So if this has helped you in any way, don't forget to leave a like, and if you have any questions, leave them in the comments below and I should get back to you as soon as possible.